now we're going to do exponential equations, okay? And then question exercise 7. Question says solve for x. A 3 raised to the power of x is equal to 0 is equal to 1. Okay, I would like you to remember the law of exponent that says that any number raised to the power of 0 is just equal to 1. Okay, so in cases like that, we can. Okay, let me just move a little bit up there. Okay, 3 to the power of x equal 1. We can solve this as by saying that x equal to 0. Okay, and then b, we have like 2 to the power of x equal to square root of 2. Now we did say that the nth root of a to the power of m equal to a to the power of m over n. Okay, so square root of 2 can be written as like when you see 2, for instance, like that, has an invisible power of 1, and then the root without any indices, understand that it is 2. Okay, so in this case we can rewrite square root of 2 as 2 to the power of 1 over 2. Okay, now that the bases are common, because we said the law of exponents says that a to the m equal to a to the n implies that m equal n. So in this case, we will drop the basis and then equate the exponents. Okay, so this means x is equal to a half. Excuse me. And then question C. Excuse me. C says 4 to the x equal to 8. So over here, the best way of solving this is like to write each numbers in terms of the prime factors. Okay, 4 is not a prime number, neither 8. So what we can do, we can reduce them all in terms of the prime factor. Okay, and then 4 will be written as 2 to the power of 2. That's in terms of prime factor, and then 8 is 2 to the power of 3. Then the law of exponents says here that any number a to the m raised to the n equals to a to the m multiplied by n. So this will be what 2 to the power of 2x equal to 2 to the power of 3. And now that the bases are common, as we just said there, we just drop the basis. As we said, we mentioned it over there. Over here, we drop the basis and then equate the exponents. This will be 2x equal to 3, and then to get the value of x, we divide here by 2. We divide it also by 2. We divide by 2 because 2 and 2 will be simplified, and then we have x equal to 3 over 2. And then D. Question D says that 1 over 9 all to the power of x equal to 27. Again, we can write 9 in terms of its prime factor. 9 is 3 squared. Okay, and then 27 also in terms of its prime factor is 3 to the power of 3. Now, so here the power is x. Then the law of exponents says, I'm going to write it over here, that a raised to negative m equal to 1 over a to the m. Note that these laws are useful from left to right as well as from right to left. Like in this case, we start from what is here in this form to this form. 1 over 3 squared, okay, can be written then as 3 to the power of negative 2. So this is like 3 to the negative 2, okay, all to the power of x equal to 3 to the power of 3. And then when we times exponents, following this law of exponents, this will be 3 to the negative 2x equal to 3 to the 3. Then we can say 3 to the, okay, over here we can just drop the bases, okay, and then equate the exponents. Then this will be like negative 2x, negative 2x equal to 3. Now to get the value of x, we divide by negative 2 both sides, and then this will be x equal to negative 3 over 2. Okay, and then e is 16 multiplied by 16 to the power of x equal to 64. Okay, we can first get rid of this 16 here. Okay, if we divide this side by 16 and we divide it also by 16, and then this will be 16 to the power of x. Okay, I've said that because this can be cancelled out, and then we have 16 to the power of x equal to 64 divided by 16 is just 4. Now we can write 16 in terms of its prime factor. We can write 16 in terms of its prime factor, which is 2 to the power of 4. And then 4 in terms of prime factor is 2 to the power of 2. Now this will make 2 to the 4x equal to 2 to the 2. Then we can just drop the bases here and then equal the exponents, and that makes what? 4x equal to 2. Now that makes to get the value of x, we divide by 4. We divide by 4 both sides, and then x will be equal to a half. Okay, and then f question is like 3 to the power of x plus 1 equal to square root of 3 over 3. Now let's reduce this. This is going to be like 3 to the power of x plus 1. We can do this different ways. Let me just write it this way. I prefer to write it this way. The question says like 3 to the x plus 1 equal to square root of 3 over 3. So one way of solving this can be by doing like 3 to the x plus 1 equal to root 3. Root 3 can be written as, root 3 can be written as 3 to the power of a half. Okay, because there is invisible exponents here and the indices there is 2. According this law, the nth root of a to the m equal to a to the m over n. Okay, now this is over 3. Now this can be 3 to the x plus 1 equal to 3 to the a half multiplied by 3 to the negative 1. Okay, because there is an invisible exponent there of 1, so we can move this 3 to the 1 on top there, and then it will have a negative exponent. Now we can combine like terms. That's going to be like 3 to the power of a half, 3 to the power of x plus 1 equal to excuse me. Okay, equal to 3 to the power of a half minus 1 is negative a half. Then we can just drop the basis here, and then we equate the exponent. So this means x plus 1, bring it this way, equal to negative a half. So if I move the positive 1 over, that makes x will be equal to negative 3 over 2. This was one way of solving this problem. The other way could be, it's quite unusual, but much easier. 3 to the x plus 1 equal to 3. Over here, square root of 3, let me just write square root of 3 over, instead of me writing 3, I can break it out into square root of 3 times square root of 3, knowing that this all together makes 3. All this is just 3. Okay, this 3 at the denominator. Then we can simplify this with that, and then this will be 3 to the x plus 1 equal to 1 over square root of 3. Okay, 1 over square root of 3, and then this will be like 3 to the x plus 1 equal to 3 to the negative a half. Why am I saying negative a half? Because this is like 3 to the a half, and because it is at the denominator, we can write it like that. Then we can just drop the bases, okay, and then we'll have x equal to x plus 1 equal to negative a half, and that means x is equal to negative 3 over 2. Okay. Excuse me. And then can do the next question is g. G is 4, and then 1 over 4 to the x plus 1 equals to 8. Now, we can write each term in terms of the prime factor, okay? 4 can be written as, okay, let me just write this way. Okay, 4 is like 2 to the power of 2, okay? And then that also 2 to the power of 2. So it's like, it's that, okay? Equal to 8 is 2 to the power of 3. Then over here, the fact that it is at the denominator, we can write it as 2 to the negative 2 according to the law of exponents. So this will be then, 2 to the power of 2, 2 to the power of 2 multiplied by, I don't need to do multiplication like that. I can just open brackets here, 2 to the negative 2 to the power of x plus 1 equal to 2 to the power of 3. Then this will be 2 to the 2 multiplied by 2 to the negative 2 open bracket x plus 1 close bracket equal to 2 to the power 3. Now we can combine this. It's going to be, okay, let's just write 2 to the power of 2 multiplied by 2 to the power of negative 2x minus 2. It is important here to maybe use bracket because sometimes students forget and then they just say negative 2x plus 1. No, but this times everything, okay, the whole exponent. All this, we're gonna make a product of this, okay, equal to 2 to the 3. Then we can combine, it's a product, okay, and the bases are common. We can combine everything here. So it's gonna be like 2 to the 2 minus 2x minus 2 equal to 2 to the 3. Now 2 and negative 2 falls, and then this makes 2 to the negative 2x equal to 2 to the 3. Then we can just drop the bases, okay, and then equate the exponents, and then this makes negative 2x equal to 3, which makes x is equal to negative 3 over 2. Negative 3 over 2. Then we can do h. H says 1 over 3, 3 to the 3 to the x minus 1 equal to 1 over 27. Okay, again, over here we can write 1 over 3 as 3 to the negative 1 okay, multiplied by, that's going to be like 3 to the x minus 1, okay, equal to 1 over 27. 27 is, okay, 27 here is 3 to the power of 3, to the power of 3. So we can write over here as 3 to the negative 3. And then this will be then 3 to the negative 1 plus x minus 1 equal to 3 to the negative 3. We can now again drop the basis here and then equate the exponents. Okay, this will be then x minus 2 equal to negative 3. And if we move the negative 2 over, okay, and that will be x equal to just negative 1. Negative 1, okay? And then another I is like 8 to the power of x multiplied by 16 to the power of x minus 1 equal to 1. Okay, cases like this, we don't really need to work much. So we can just say this is to the power of 0, knowing that it's going to be 1. And this is also to the power of 0, knowing that this is going to be 1. So what we can say that x is equal to 0 for this, for a to the power of x, or not or, but and x minus 1 equals to 0 also, okay? Because the power here must be 0 for both of them in order to have 1 on the right hand side. So we say x is 0 and then x minus 1 also equal to 0. Over here we can calculate x is equal to 1. So the answers are, the solution is x is 0 or x and x is 1. Okay. Now J, 3 to the power of 2x minus 1 over 3 to the power of x equal to 3. So over here we can cross multiply or we can simplify. Maybe we can do both way. One way is like to simplify, okay? This can be written as 3 to the 2x minus 1 multiplied by 3 to the x equal to 3 is like to the power of 1. Then this will be, we can combine, okay, I said it's not x, but to the negative x. Negative x. Now, this will be 3 to the 2x minus 1 minus x equal to 3 to the power of 1, okay? And that makes, over here, we can just drop the basis here and then equate exponents. 2x minus x makes x minus 1 equal to 1. That makes x equal to that makes x equal to negative 2 if we move actually positive 2. Positive 2. If we move the negative 1 over, it becomes positive 1, and then we go to positive 2. Or we can also do cross multiply, okay? Because over here we have like an invisible denominator of 1. This can be done as 3 to the 2x minus 1 equals to 3 multiplied by 3 to the x, okay? And then this means what? 3 to the 2x minus 1 equal to, because here there's an invisible power of 1, okay, that makes equals to 3 to the power of 1 plus x. Again, we drop the basis, okay? And then we equate the exponents. That makes 2x minus 1 equal to 1 plus x. So now, if I move the x, I move the x over, and I move the negative 1 over, what we have, we get like 2x minus x, because moving the x over becomes negative. 2x minus x will be x. and then move the negative 1 over, it becomes positive because we're gonna have like 1 plus 1, which is 2. Okay, that was j. And then k, it says like the cube root of 9 equal to square root of 3 to the power of 2x. So in this case, we can write 9 in terms of its prime factor. It's 3 squared, okay, and square root of 3 will be written as 3 to the power of a half, okay, all to the power of 2x. Now this is also like 3 to the power of 2 over 3. This one will transform it to that exponential exponent, and then this will be 3 to the power of x, because 2 and 2 will cancel out, and then we're going to also simply drop the basis now, and then we have like x equal to 2 over 3. And then you can do L. Question L is a to the power of x. 0.375 to the power of x equal to 9 over 64. Again, we need to write these in terms of the prime factor. Okay. We're doing this question L, 0.375 to the power of x equal to 9 over 64. Okay, we were going to write this decimal in its fraction form. You can just use a calculator like that and then write 0.375 and then hit equal. And this tells us what it is in form of a fraction. So it's 3 over 8. Then we can write here 3 over 8 to the power of x equal to, now 9 over 64 can also be written in can also be written its prime factor, but instead of just making prime factor, the fact that here I have like 3 over 8, over there I can write it like 3, it's like 3 squared over 8 squared, okay? And then because the power is like 2 here, I don't need to write that in terms of prime factor, although it will be generate the correct answer, but I prefer to write it like 3 squared over 8 squared like this, and then this will be 3 over 8 to the power of x equal to 3 over 8 to the power of 2, okay? Then one of the law of exponents is that if you have like 8 to the power of m equal to 8 to the power of n, this implies that m equal n, okay? So the bases are common, as you can see, 3 over 8, 3 over 8 there. Then this implies that x equal to 2, okay? And then we can also do question m. Question m says that 8 to the negative x minus 2 point, not point, but 2 times 4 to the n minus 1, actually x plus 1, x minus 1 equal to 0. Now, we're going to reduce the basis here in terms of the prime factor. 8 is, so it's like, it is like 8 to the power of negative x minus 2 times 4 to the power of x minus 1 equals 0. Now, 8 will be like 2 to the 3, and then 4 is like 2 squared. Then this will be 2 to the negative 3x minus 2 multiplied by 2 to the 2 open bracket x minus 1 equal to 0. Now we can also simplify. This makes 2 to the negative 3x minus, okay, over here, let's just write times 2 to the 2x minus 2 equal to 0. Now, I was saying that over here, the power, there's an invisible power that is 1 there. And then this will be 2 to the negative 3x minus 2 to the, we add exponents, that makes 2x minus 1 equals 0. Then if I move this over, I move this term over, and then this will be 2 to the negative 3x equal to 2 to the 2x minus 1. Now that the bases are common, we can just drop the bases and then equate the exponents. That makes negative 3x equal to 2x minus 1. And then our group, that makes, if I move the 2x over, that makes negative 3x minus 2x equal to negative 1. And this will be negative 5x equal to negative 1. Now we can divide both sides by negative 5. And then this will be x equals to 1 over 5. Okay. We can also calculate question, do also question n. That says 6 to the power of x plus 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 6 to the power of x, all equal to 6 to the power of 6x. Okay. We do not really have like laws for adding exponential terms that have same base, but the fact that they have same bases, all of them like 1, 2, 3, 4, 5, 6. There's 6 terms here, and they're all 6 to the power of x. So we can just say 6 times. We can shorten that into by writing 6 multiplied. So 6 times 6 to the power of x equal to 6 to the power of 6x. Okay, and then 6 like this means there's an exponential, the exponent there of 1, and then we can apply the law of exponents for same bases. We add the exponents, so we can just say this is 6 to the power of x1 plus x or x plus 1, okay, equal to 6 to the power of 6x. Now that the bases are common, okay, this implies that the exponent will also be common, so that makes x plus 1 equal to 6x. So I can move this x over, and then that's going to be like 1 equal to 6x minus x. That makes 1 equal to 5x. And then to get the value of x, we divide by 5 both sides. We divide by 5, and that makes 1 over 5. Okay, so x is just 1 over 5. Thank you.